all of you have seen. It's not working. Okay. Thanks. All right, so let me talk a little bit about CNI. So this is the this event is hosted by Linux Foundation and CNI jointly. CNI is a center at ISC where we do industry-sponsored research, and we focus on network and systems. This is affiliated to a division of electrical and computer science, and also by interdisciplinary center on cyber physical systems. And here is a list of some of the activities which we perform. So in fact, the center was formed just pre-COVID, and COVID came, and suddenly we started working on pandemic response like the rest of the world. And I specifically work on data center and cloud. I'll talk a little bit more about that. We also have 2 test beds, one on industrial control systems and one on tactile cyber physical systems. We also do some Wi-Fi optimization, and one faculty leads this, and we do cellular network slicing. So, so we not only do academic research, we also try to develop proof of concepts and give a demonstration. All right, so here is a little bit more about the data center networks and cloud research group. So we focus mostly on computing, maybe on the cloud and the edge. And these days we also got interested in creating infrastructure for ML. So sort of like we are the plumber for modern applications, and we also do specific things for private data center as well. I mean, we can go into details if you guys are interested, but I'll quickly just run over these things. So why we are interested in eBPF? So it's a little bit more about how we started, how we decided to organize this workshop. So the one thing which so I come from an like more performance background and like more math modeling and less systems. But Preetham here is an expert in system, and we started working together. One of the reasons I stick with networking was it is easier to implement compared to wireless, right? Which requires way more investment from or you need to people in the industry to be able to implement anything. But even in networking, it turned out that if you want to change scheduler, there is a very high barrier for entry. So this is how we got interested in eBPF. And so Preetham has connections with Linux Foundation. We started talking, and we talked to our collaborative industry, and we thought that okay, maybe this is a new technology which we need to learn a little bit more. So that's how this workshop came into being, and hopefully this workshop will help us learn some of the things which we were talking about. We want to specifically figure out how to leverage eBPF to in the systems and the networks which we are looking at, and maybe learn the tools and the ecosystem. Also build a community. So if we get stuck, then we can talk to each other and figure out how to help each other, and maybe build a larger system community, people who are working on performance, from different angles, right? So this is the overarching goal. And maybe a little bit about today's speakers. So I think Brendan does not need an introduction, but still maybe a few lines about him. So he's known worldwide as the shouting guy. Okay, which has earned him a mention in the children's science book, Carl, the Universe and Everything. He's also he's blushing on the camera. He's also an industry expert in computing performance and eBPF, and he solves hard problems and makes things faster. So I mean, he's the only one, he could not fly from Australia to here, but everybody else is in-person speaker. Finally, a small plug for our center. We are actually hiring. So we have, this hiring season is here. So we're gonna have research admission for PhD students in May. So we're looking for students who are interested in performance, either in systems or theory. And there are opportunities which are on my webpage and the CNI webpage, and we'll add few more as we go along. Okay, we're also looking for project assistance. That's it. So with that, Brendan, you can take it away. Thank you. Welcome you all. Yeah.
Great, thank you. Let's just switch screens.
Yeah, you have stopped sharing. You can start sharing, Brendan.
There we go. Can you see my screen?
Yes, we can see you.
Well, thanks for the introduction, and thanks to IIS for having me. And I'm excited to talk about eBPF. I'm also excited about what's happening in 1 week from now, which is the Indian Premier League. Go Chennai Super Kings. No, wait, that's the wrong team. Go Royal Challengers Bangalore. Now, I do think the Royal Challengers will win because it is Glenn Maxwell, and he's had a great season so far in Australia. So looking forward to that in 1 week from now. At the moment, I'm going to talk about eBPF, and this is actually my first talk to India, although I have been to India a number of times. This is a picture of myself and my beautiful wife, Deirdre, in Jaipur at Juntamunta. And Deirdre is on the board of Woodstock School. You may know me from books, Systems Performance and BPF Performance Tools. And both of those include a lot of eBPF. So I'll start by just describing what eBPF, because it is a complicated thing to get your head around, and it helps to have different people try and explain it so you can really have a concrete understanding. I've described it as superpowers, but it's also like how JavaScript allows new applications in the browser. eBPF allows new applications in the operating system kernel. So we can change the kernel. We can have networking products. We can have security products. I do a lot of performance observability products. It is performant and it's also secure. So you can run programs safely in the kernel. What it actually means is previously there were some startups selling interesting ideas for security monitoring or networking, this and that required kernel changes, which were difficult to accept for production environments, or they required running kernel agents. And that is a security risk. For a long time, I worked at Netflix, and to run an agent from some third-party startup as root certainly would make us very nervous. eBPF, however, runs programs in a sandbox. And so it's making possible these ideas that previously couldn't really get off the ground and couldn't really attract customers. So we're just at the start of all the different things we can do with eBPF. Where we're at now in 2024, just to give you some highlights, the major applications, BCC, Cilium, and BPF trace are where a lot of us work. BCC is the compiler toolkit. BCC, we started that in 2015, and it has evolved over the years. So it does include a lot of my performance tools that you can run, and man pages and documentation. But we've also been working on rewriting those using, originally that was Python, but the new interface is in C, using libbpf, using core, which is compile once, run everywhere, using BTF, which is the BPF type format for the kernel types. And so within BCC, there is a new group of tools written using libbpf. And when we have time, maybe in 2024, we will officially obsolete the Python parts out of BCC and say people really should be working on the newer core stuff, the BTF stuff. It has various advantages. One of them is that it can build these relocatable ELF binaries that contain BPF programs that you can then run on different systems, including embedded systems, including Android phones. And so previously there was too many libraries that needed to be handed around for that. BPF Trace is another observability product I worked on, and that provides a high-level programming language. So it's great for scripting. It's great for ad hoc tooling. And that's been coming along very well. Cilium was the #1 startup example because the startup Isovalent has done so much work to contribute to eBPF and open source. And we heard late last year, Cisco has announced that they would acquire Isovalent, but Cilium itself is used for eBPF, networking, security, and observability, and Kubernetes in particular. So there are many applications. These are the major ones that a lot of us work on. And I've got a couple of infrastructure things here. eBPF for Windows. Many of us have been involved in the eBPF Foundation, where we've been exploring allowing eBPF to grow beyond Linux and coming up with an IETF standard for the BPF bytecode to allow Microsoft to do their own implementation. And that will also eventually allow Apple to do an implementation for OS X and for BSD to do an implementation. That's coming along really well, and Microsoft have had various announcements about their progress. Another really exciting one is BPF time, a user space eBPF runtime that may really reduce the overhead of user space tracing. This is an emerging area. If you look at a lot of the tools that I've published in BCC and BPF Trace and in my book, I spend a lot of time in the kernel. And the reason is kernel tracing, if you're doing K-probes, the overhead is about 69 nanoseconds per call. But if you do user space tracing, it uses more of an old-fashioned technique to interrupt the kernel using an int3 breakpoint or fast trap. And that the minimum overhead there can be about 2000 nanoseconds or 2 microseconds, which is way more expensive than kernel-based tracing. That's 50 times more expensive. What that means is, as a performance engineer, I'm very worried about the overhead of all the tools I create. So kernel tracing, the overhead is acceptable. It's pretty low. But for user space tracing, I was very nervous. If you want to do like memory leak detectors where you're tracing malloc, you want to look at, say, plain text encryption as it's doing I/O, reads and writes to an encrypto library or whatever it is, I'm much more nervous. And so I haven't published many user space tools, but things like BPF time may solve that problem so that user space tracing is as cheap as kernel tracing, and that will open the door to many more tools, which will be really exciting. I want to talk about, it's easy to talk about BPF. Nowadays, there's a lot of documentation and talks, but one thing I want to emphasize now is what would be best for you to do if you're showing up to eBPF today. And a lot of people in the industry, they think of eBPF as a programming language or a programming runtime, and they think, I need to program it. I'll tell a story to help explain what I think you should do differently. So back when I started my career in the early 2000s, computers were connected using thick Ethernet, vampire taps, dumb hubs, and you could run a network sniffer on a computer and see everyone else's plain text packets. If someone connected to a host using Telnet at the time, you could see their username and password as they typed in the keystrokes. If someone FTP'd to a host, it was even easier because the username and password was grouped on one packet. So what companies did was they said it was a fireable offense if you were to run network sniffers, because otherwise people could see each other's passwords. I actually started my career working as a university system administrator, and students could look at staff member passwords, and it was not secure at all. Encryption was exciting because it meant we could encrypt all of those packets and so provide security. It's a no-brainer. But when encryption was first introduced, a lot of people saw it as something they had to learn to program. I got involved. I was working, ended up working for Sun Microsystems, and I ended up teaching classes on how to write cryptographic algorithms. I used to carry around Bruce Schneier's textbook, Applied Cryptography, and I used to be able to whiteboard the DES crypto algorithm. And that's what we were doing. Everyone was learning how to write crypto algorithms. In hindsight, that was really dumb. People did not need to learn how to write crypto algorithms. All they needed to do was to use OpenSSH or OpenSSL and use a library. Why is everyone having to code their own library? But it just seemed like that's what we should be doing. And so we were all learning crypto algorithm internals. What would have made more sense is for there to have been a focus on people using crypto, not coding crypto. And so to go to companies and draw up the network stack and diagrams, find out all of the parts where there's plain text, and figure out how to apply encryption to each of them. And that would have been much more helpful to companies and not wasted a lot of people's time. I use that analogy because it's very similar for eBPF. is it's a very new thing. People are wondering what they should be doing, and so they're learning how to code in eBPF. But you'll be better served yourself and your company, and also the eBPF community, if you use eBPF first and then code later if you need to. And by use eBPF, I mean takes, for example, the open source performance tools and find wins. Find your company millions of dollar wins and then write blog posts about it to share how useful they are. I've got an example there. There was a recent blog post about Kafka's tackling tail latency with eBPF, which used some of my tools and techniques. It's really great to see that published. That's helpful because it helps eBPF grow as well. If you're a company, would you invest in eBPF if people said, oh, it's a new programming language, we need to learn it, it's going to take a lot of time? It's better if people have published examples of the return of investment, like this blog post, to say eBPF can help save millions of dollars. That's a much easier way to get for there to be investment and for companies to spin up teams and individuals to help the eBPF community. And then later, after you've made your company lots of money, then you can code in eBPF if you want to. And so you can see how I'm changing the order that people do things. It would be like getting into crypto and saying, well, I'm going to start by using OpenSSL and making sure my company is encrypted. And then if I need to write crypto algorithms, I will then learn how to write crypto algorithms. But get the use of it first and then code later. eBPF is we're at the beginning where we've got a lot of things working. It's in the Linux kernel. Microsoft are adding it to Windows. And so now's the time to be exploring and coming up with use cases and seeing how we can change the industry. So it's an exciting time to be trying it out. One thing that I've been looking into is this idea of fast by Friday. An issue I see is that it takes too long for us to understand the performance of issues, especially doing evaluations of, say, hardware or software products. I now work at Intel and I get involved in this a lot, where you have a deadline and you need to compare the potential customers comparing Intel versus someone else, and they need to get to the bottom of performance so they can make that decision and make sure both sides are fairly tuned. But it takes too long, like to get to the bottom of performance of two different hardware setups. I think with eBPF, we can have this vision where any computer performance issue reported on Monday can be solved by Friday to give us a 5-day deadline or sooner. Now, we really need it because computers are getting increasingly complex. And I've seen this from my career in computing, where it used to be when I started, I used to teach performance classes for Sun Microsystems, and I used to be able to cover everything in 5 days with the exception of middleware, because middleware was already big and sprawling. Nowadays, it would take much more than 5 days to cover all the different things you need to know, because we have not just different programming languages like Java, but there's also runtimes within the programming languages, all the different Java implementations. And then there's different compilers and garbage collectors. There's Kubernetes, there's service mesh, there's cloud computing, there's hypervisors, there's the lightweight virtual machines. There's just so many things to evaluate and understand these days. This is why it's even more important to think about how do we not just get to the bottom of performance, but do it faster. On the slide, I've got an example of how in hardware things are getting more complicated. Intel's shipping accelerators on the Sapphire Rapids processors, things like DSA and IAX and QAT. Who has time to really dig into those and get to them and find out if they can be turned on to improve performance? This is why it's great that we have all of these options, but we need to more quickly get use of them. With Fast by Friday, my proposed agenda is we prepare systems so that they can be debugged to start with. And then from Monday through Friday, these are the activities sorted in order from most likely to find a performance issue quickly to things that are more time consuming and difficult. And as it turns out, 3 of these areas are greatly improved with eBPF. And I've got a separate talk where I get into the details of Fast by Friday, but I just want to look at those 3 areas. So the ones I'm skipping are preparation. That's where you need to prepare systems so they can be debugged. So for example, you want there to be debuggers installed by default. You want there to be stack walking should work by default like frame pointers. You want there to be symbols or debug symbols if you need them installed by default. You need SSH access by default. On Monday, that's the simple things like what if you think you've got a performance issue, quantify it. Can you express it in terms of latency or runtime? Do static tuning, which is where you just look at the system at rest and see if there's any dumb configuration mistakes. And then check if it's just a problem of load, if there's increased load, and that's the simple answer for why there's a performance issue right now. So those are the 2 ones I'm skipping. Then we get into eBPF. So checklists and elimination. Got a diagram there of eBPF performance tools. These are open sourced. I wrote a lot of them. The current world of eBPF performance tools are things like my Snoop tools, which do line-by-line ad hoc logging, top tools, stat, count, slower for doing latency thresholds and doing distributions or histograms. They're great for doing later methodologies, but I'm now pushing the creation of new tools, which would be health tools or diagnosis tools to support this Fast by Friday methodology. These elimination tools, their role is to exonerate components and to say, this component's healthy. You don't need to debug it. You can forget about it. So I can imagine in the future, we can have a dashboard which will run all of these, mostly eBPF exoneration tools, and it will tell you all of these subsystems are healthy. They don't need further debugging. These other ones do. I was actually reminded of it because while I was working on this methodology, my Intel MacBook broke. And what do? Well, you do Apple D and you power it on, you do a diagnostics boot. And so I did that. It went through its diagnostics boot. It was a performance issue. It was running really like pathologically slowly, where the mouse pointer would only move once every 10 seconds for like half a second. So do the diagnostic boot and it works through all of the different components. And then it says the IO card is the problem. It's like, great. So I took it to the Apple repair store. They did the exact same thing I did. They went through the diagnostics boot and it said the IO card is the problem. And I'm like, this is what we need. This is what we need for servers so that if you're working on backend servers, you've got a similar diagnostics that can tell you, don't worry about all of these other growing complicated parts. It is just this one part that is the problem. And so that's why I want to push for these new tools that help us do that. Then there's profiling, which eBPF helps with as well. CPU flame graphs, this is a prior invention of mine. It's more efficient with eBPF because we can aggregate stack traces in the kernel and emit just the summary. We can also write custom eBPF runtime stack walkers to get more information out. Then there's off CPU flame graphs. CPU flame graphs just show you the CPU time. I also want to look at the off CPU time when you're blocked and waiting on various things. They're impractical without eBPF. The 2 of these will solve most performance issues. You do need the prep, and eBPF is critical for this. And then the Thursday, as part of Fast by Friday, that's also helped a lot by eBPF. If your performance issue makes it to the virtual Thursday, this is where you're doing latency drill downs, using some of the existing eBPF tools that do distributions slower, then logs and event tracing, and then critical path analysis, which I think in the future, when faster uprobes is done, which I just talked about earlier, then we can have zero instrumentation analysis and a whole bunch of new tools for helping out there based on eBPF. So that's the Fast by Friday summary. So any computer performance issue reported on Monday should be solved by Friday or sooner. And this previously would just be this academic vision that we couldn't get off the ground because there's just so many things we would have to change. It would take decades. with eBPF, we can start, now that eBPF is mature enough that people have it running on their systems and it's in their kernels, we can start building these tools. And where I think the actual location for a lot of these tools, the exoneration tools in particular, should be is in the target code, like a test suite. So if I do an exoneration tool for the XFS file system in Linux, that should go into the Linux code base, and I should work with the maintainers of XFS so that they can help me identify how to exonerate it and all of those internals, because these will be very tricky tools to write. I'm looking forward to this point. It'll be super important for the industry, because if we can solve performance issues in 5 days, it means that the products, for example, the products that Intel's working on, but the products anyone's working on has a better chance of success. And I'm trying to prevent the situation where people do these evaluations and they just run out of time and they just pick one product and say, well, we need to go with something. Let's go with this product. And that does not reward engineering effort. It doesn't greatly improve performance. It's bad for our jobs. It's bad for the environment. It's bad for our companies. We really need to get faster at performance analysis. So this is why I think this is a super important mission of mine, but it will take years to develop. So those are 2 important things I wanted to talk about. One of them is for you to use eBPF today. There are a lot of open source tools and projects ready to use. So use now, share stories. That helps all of us to get more investment in eBPF, and then write code later if you need to. And Fast by Friday, that's the exciting thing I think I'm working on at the moment. To any computer performance issue, we should be able to solve this in 5 days. Now, that's all the slides I had, but I'm happy to discuss eBPF a bit more. Let me just unshare my screen. And I see there's some Q&A. Will the slides be shared? Yes, I can share the slides, and I have longer talks on Fast by Friday and other eBPF topics.
Thanks a lot, Brendan. Anybody has any questions for Brendan? Okay, I think it's too early. Yeah, just a second. There's one question.
Hi, Brendan. Thanks for talking to us today. I was like, earlier there used to be emails and stuff where you could talk to eBPF folks. Now I do not know where we need to talk to. Is it the Cilium Slack or anything? And one eBPF question is like, I have not seen how do you say loader, the linker and loader, how do you instrument the time it takes to do that? So that is the one that I wanted to know.
Okay, so 2 questions. One, how do you talk to eBPF people? Whoa, my mailbox is so full. Everyone wants to talk to me. The problem right now is there are startups who are hoping to sell for hundreds of millions of dollars doing eBPF this and eBPF that, and they are desperate for our help. It's tough. When in some ways it was easier back 5-10 years ago when eBPF was not that exciting, and there was just a bunch of us trying to get things done. But at the moment, everyone wants to talk to us, and that just happens with success, right? How do you actually talk to us? One of the best places is conferences, and because when we go to the conferences, we block off time, and it's like during these 3 or 4 or 5 days, I am available to discuss anything with anyone. And I'm not in front of my work laptop answering emails. I'm just available. That's when people get the most questions in. There are generally 4 major conferences a year where you'll run into a lot of the eBPF folk, and they move around a bit. You've got LSFMM-BPF. The next one is in Utah in the United States. That happens once a year. You've got Linux Plumbers, which I think that's in September this year, and I think it's going to be in Vienna. Then there's kernel recipes, which happens later in the year, and that's always in Paris. And then there's the Maintainers Summit. I'm often at one of these, and so is the other eBPF people. It's handy because, like I said, we've blocked out our time. So we are there to answer questions. We are there to talk to people and help you out. If you can't make it to one of the conferences, the Cilium Slack should be fine. I'm logged into the Cilium Slack. You can find me there. There are mailing lists. So there is I think it's still called the iAdvisor Dev mailing list. iAdvisor was the original name of the eBPF Foundation, but it's now called the BPF Foundation. But a lot of us are still subscribed to the iAdvisor Dev mailing list. That's another way to find us. If you're working on one of the repositories, like you want to work on BCC or BPF Trace, GitHub tickets, and we discuss things in the tickets. BPF Trace itself has office open hours. They often, for me, are the middle of the night. So I try to attend the ones that aren't too late. So it really depends on what you're trying to do. So if you're working on a particular project, have a look, because we try to put on the GitHub, like where's the chat rooms? What's the mailing list? Are there office hours? And then there's also conferences that we attend as well. Your other question was really interesting about LD latency. So linker and loader latency, I don't think anyone's written a tool for linker and loader latency. Maybe there's performance issues that have been undiagnosed forever. So please go ahead. Please give me LD stat or LD latency. LD slower, maybe that should be it. LD dist. So yeah, I'd love to see some tools that gave me the latency of LD. At the very least, to exonerate it as being an issue. So I assume the linking and loading is pretty quick, but if it's not, that would be a good thing to know. So I do not know of tools, but you can go ahead and create them in BPF Trace or BCC, and maybe they'll end up being run by lots of companies and find some interesting things. Okay, I have a few other questions.
Yeah, one more question. Hey, thanks for the question.
How can eBPF programs help in AI-driven storages? So I don't know what you mean by AI-driven storages. So for AI, eBPF has already been used for things like looking at the latency when you're sending accelerators their kernels to go and execute, and getting an understanding of the driver internals and what it's doing when it's talking to one of these accelerators. So, and I'm working on a similar area, so I understand that use, but I just don't know the driven. You can put another message so I can better understand the driven storages. Someone says, I have an app that is a container. I can send 17,000 requests per second. When I increase to 100 concurrent questions, latency increases. What tools help me sort out these issues? Latency is bread and butter for eBPF tools. So off-CPU flame graphs is a good one I would go to. You kind of, whenever I look at a performance issue, I like to understand straight away, is it on CPU or off CPU? If it is on, if your CPUs are busy, do a CPU flame graph, and then you can look at the code paths. If it is off CPU, you can do an off CPU flame graph, which is all the blocking time, which is great because previously we'd have to guess and we'd try disk and we'd try network and we'd try locks until we kind of figured that out. So have a look for the latency tools, the slower tools for the latency increases, and it also includes scheduler latency. You talk about increasing the concurrent connections. So if that pushes the CPU scheduler under a lot of load, it could be scheduler latency is responsible. There's one in BCC called Run Queue Slower that will help out. And I think Red Hat added that particular one. So Red Hat has a way of running the BCC tools, but if you're on other OSs as well. The last question I've got, nope. Next question in chat is, how is Leaf L3AF useful? I'm using multiple eBPF tools for my application flow. So eBPF is great. And I've just mentioned a whole bunch of things. There's BCC here and BPF Trace here and Cilium there. if you think about it, you think this is starting to be a mess. Now, if you think about Linux, how do we deal with that mess? We have package repositories. If you're talking about just general software, so you can apt-get install this or yum install that. So what about package repositories for BPF so that we can mature the delivery of eBPF programs? Leaf is one of the projects. How useful is it? As far as I know, it's useful. It's just watch that space. And if you're into that sort of thing, I would help them out because I believe that's an open source project. And then GPL license worries seem like the next question. GPL license worries, the main worry when coming to make use of eBPF and commercial tools, is there any work being done to ease the strictness? I mean, I'm not a lawyer. I've encountered these licensing things many times. I would have a look at what Cilium did. They've done a lot of work into, I mean, they also helped drive the relicensing of when we were taking libbpf from Apache and moving into the kernel tree as GPL. So there's ways to do it. There's ways to, that the Linux has ensured the BPF bytecode itself has the license tag so it knows whether it's GPL or Apache or whatever. And if it's the wrong license, it will taint the kernel and you'll get a D message. So yes, there's work on that area. As far as I understand, there is a solution, but I'm not the expert in telling you how. I'd have to look it up myself. So that's the best answer I can give you there.
Brendan, we have one question from the hall.
Sure.
Brendan, thanks for the talk. Actually, I really like the point that you mentioned that eBPF is a powerful language, but to basically get the benefit from the language, you don't need to write the tools yourself. You can use the existing tools. So from what I understand, like that applies to the things in observability and particularly the performance side very well, because on performance side, you need to debug certain things and there are basically small programs which you can attach multiple of them, build a larger set of performance diagnostic tool. Do you think that same logic applies to something like the field of networking, where essentially you need multiple of these network functions to build a big software which can do many more things, like Cilium, for example?
Absolutely. And so we got to the point of observability and those tools becoming the primary use case because it was lacking in the Linux kernel. And that helped eBPF get merged in the Linux kernel originally when eBPF was seen as another open vSwitch or another networking protocol, a networking technology that the Linux kernel may not need. And so in some ways, I helped show a particular use case of eBPF, and I did all of, it was great that Netflix gave me the freedom to do all of the open source tools, but I could have done it on networking. And like today, we could have had like 100 network, that's a suite of network tools. Bearing in mind, BPF, which nowadays is not an acronym, but is originally the Berkeley packet filter, that comes from networking. And Alexei Startoyev, who came up with it, was doing it for PlumGrid, a startup that was doing software-defined networking. So it comes from that space. The reason we don't have a big suite of little network, general purpose networking tools, I should say, is just the way things felt. I showed up and I was doing tracing and observability tools, and they really fulfilled a need. And that's what we used as the primary examples. But I could have done something else. I could have done networking. I could have done security. I could have done application accelerators as another use case. Cilium has focused on Kubernetes, but now that Isovalent has been acquired by Cisco, we don't know what they're going to do with it, but maybe that's something they could do in the future, is networking tools. If you have an interest in it, then go ahead and create the tools. And the great thing is you can use them in production, get some real experience, and share them openly. So yeah, there's no real good reason why there's not a bunch of networking tools yet. It's because you haven't created it yet. So please create it.
Hello. Hi, Brent. I'm Shiv. So I just wanted to know, about this eBPF object files. So, like, I want to know, like the eBPF program is compiled to a object file which is of format ELF, BPF ELF64, right? So I just wanted to know, like, from where I can understand more about this ELF file, because I found very less. I think there are documentation, but those documentations are very imprecise, and I was just searching for the updated information about these ELF sections and ELF files.
Yeah, I mean, this is one of the things about eBPF is it is so new that when I got involved, there was no documentation. And I started creating tools, and it was Alexi that told me that, Brendan, it would be nice if you created a reference guide, because we have a lot of people trying to learn eBPF. We had no reference guide, right? We had very little. So it gets better over time. We go and document bits and pieces here and there. As for the ELF format, I would check if Andre from Meta/Facebook has, because Andre Renko did do some blog posts on core, compile once, run everywhere, and like how it does the relocation, symbol information. Did he delve into the ELF format? I'm sure he would have touched on it, but he would be the person. So look for the blog posts from Meta on core, co-re. That's where I would go and look to see, like, is there stuff on the internals? But other than that, ELF itself has a big suite of debuggers, so you can dump out all the ELF sections and really pick through it. So there's I forget the name. There is a suite of ELF tools that will show you in the internals. But has someone written the reference on BPF in ELF? Not that I know of. Maybe you can write it.
Is it working? I have a question, Brendan, here. You talked about the standardization of eBPF VM. Do you think the eBPF will become the de facto observability even for embedded systems, which may not be running this big OS like RTOS, or maybe somebody can implement if the reference allows it? And the second question is, do you think that eBPF is, a lot of people are talking about security with the eBPF, but my reading into it is primarily an observability tool. So do you see a gap going from observability to the, let's say, IoT security, or what kind of work needs to be done before eBPF can be used as a foundational tool for security as well? I understand that security starts with observability, but I just wanted to pick your brain. What is your reading into the community effort towards standardization deployment on non-Linux, non-Windows operating systems?
Yes, so the first question is, will eBPF be the de facto observability for embedded? ftrace is pretty good on embedded because ftrace is already built into the kernel, and that has a wide audience. eBPF, ftrace, I like ftrace. I can get things done in ftrace, but there are some things that I can't get done and I need eBPF for. So it is useful. Things like core and BTF were important for getting embedded BPF to work. There's the Ply project by Tobias, which is like BPF trace, but much more stripped down, and that was aimed at embedded. So I think eBPF will be used on embedded, and I believe it already is used by Meta for some embedded use cases. But it's in some ways, most of the eBPF's history has been the heavyweight LLVM, Clang, Python, BCC repository. And that's why you don't see a lot of blog posts about eBPF on embedded, because for most of the history, it's been heavyweight. It's been too heavyweight. Only in the recent years have we gone down core BTF in the kernel, and can we now explore that? So there should be more in the future, absolutely. As for eBPF for security, yes, of course. There's only one Brendan. I did a whole heap of observability tools. I could have done a whole heap of security tools as well. I did a security chapter in my BPF book, and I did do some tooling. It's a great place for doing host-based intrusion detection systems. You can also do vulnerability mitigation. There is some prior work in this area. Like if you look at what Red Hat does with System Tap, they'll come up with these mitigations for CVEs and say, so you can basically live patch the kernel through a tracing program. BPF can do that as well. So it's not just for security detection, it can also be used for enforcement and mitigation. At the moment, I'm on the hook because I did do a blog post about the sort of work you need to do to go from observability tools, which have a certain set of requirements, to security tools. Because my tools that I've published are observability tools. I know they have time of use. They're vulnerable to time of use attacks and various other things, as are the standard Linux tools like top and VMstat and whatever. So if you turn them into security tools, you do have to do a bunch of work. I'm going to do another piece of documentation, which I'm on the hook for, about the same topic, about how do you go from observability tools to security tools. So yes, there are already startups doing eBPF security, this and that, and I think there's going to be a lot more. Like I said, it's a great eBPF. If you're in security, you should see eBPF as your friend, not your enemy, because it will help you accomplish a bunch of goals. And like zero-day detection and mitigation and a lot of things, because you can just write a little program and say, oh, we've got this buffer overflow on this kernel function. If this argument is set to this, here's a BPF trace program to examine it that you can push out to your cluster to see if it's happening, but also to mitigate that. And so the advantages are really awesome. So absolutely, lots of uses in security. I had one question that's easy to answer on the chat that says, how can we leverage eBPF with P4? Can you give some inputs? P4 is the networking programming language that Intel has for its SmartNICs. And how can we use eBPF with P4? I haven't used it, but I believe there is an eBPF to P4 transpiler that will convert eBPF programs into P4, so you can then run them on SmartNICs. There has been some SmartNICs over time that have supported eBPF directly. Was it Mellanox that did that from memory? So yeah, eBPF and P4, definitely a thing. I don't know of a canonical documentation. Like I said, things change so fast. So you're often at the point of like, there's no documentation and you're just figuring things out. And I had, can Leaf manage eBPF-based tools? Or can we just write our own eBPF programs to be attached to XDP TC hooks? I haven't used Leaf. Leaf is the BPF package repository that some people have been working on. You can just write eBPF programs to attach to XDP TC hooks. But if you want management of those programs, you may want to explore something like Leaf. And I saw the microphone being passed. So was there another question from the audience?
Hi, Brandon. So I wanted to ask, like, there are kfuncs, right? So they are not stable. So what do you think, like, if I use those kfuncs, are they like deleted from the source code or something like that? Like, what is the stability thing I can expect from kfuncs?
So if you're doing kernel tracing, there are, if you actually look at a lot of my published tools, you'll see I use kprobes a lot. And the reason is I wrote them in 2015. And I just haven't had time to really go and rewrite a lot of those tools. I've been trying to get other people to do it. If I were to write a lot of my tools today in 2024, you'd see I would try to use trace points as much as possible, or kfuncs because they're a bit faster, and kprobes would probably be a last resort. So I think a lot of my published examples are probably giving people the wrong idea. And it's because that's when I wrote, that's what we did in 2015. We did kprobes. So the problem with kprobes, as you've just said, is that it is an unstable interface because you're tracing kernel functions. And the kernel can change from minor version to minor version. The ultimate solution to this is trace points. Trace points is the stable API. However, Linux maintainers are reluctant to add a lot of trace points into the kernel because each trace point is a maintenance burden. The more recent work with kfuncs and BTF actually makes if the trace points don't exist and the kernel engineers refuse to accept adding them, then you'd use kfuncs, and they can work with BTF, and that can take some of the stability churn, solve some of the stability churn for you. If you're doing kprobes the old-fashioned way from 2015, yeah, you have to keep maintaining those tools. Each time there's a kernel release, you need to check if they still work, and then do an if-def, this version of the kernel do this version of the kernel do that. It's horrible. It's horrible. That's why we have trace points. We can't get trace points everywhere. If you've got this thing that you're doing with kfunc or kprobes, and you're like, this is so important, I'm using it all the time, it's so valuable, you can use that value and that production proof to make the case for trace point addition. So yes, you should try to find trace points. If they don't exist, use kfuncs and kprobes, and then spend a couple of years getting the production use cases. Then you may be able to convince the maintainers to add a trace point.
Hi, Brendan. Thanks for a wonderful talk. How eBPF and as well as UDP load balancer along with XDP, can you shed some light upon those use cases as well?
I have not worked on that kind of area for a while. So Meta does have the Catron eBPF load balancer. And I mentioned something earlier about kernel tracing. With load balancers, I worry about tracing every packet and the overheads because packets can be millions of events a second. However, kernel tracing can get down to 69 nanoseconds just as the base cost. That's pretty quick. And so you're on a 64 CPU server, you're doing 1 million packets a second. It might be 64 nanoseconds per packet base cost for eBPF. So you're talking 64 milliseconds spread out across 64 CPUs, say, so 1 millisecond per CPU. So you can start to see that on a big server, if it's like 69, 70 nanoseconds, yes, you can do per packet stuff. You can do load balancing, and you can do those things. What you can't do is go down into user space where the cost is maybe 2.5 microseconds per event, because then the overheads add up. It's all mathematics. It's all multiplying the overhead of the event with the rate of the event. So yes, load balancing is a thing. That's where BPF comes from, or eBPF comes from, is doing software-defined networking and load balancing. But I'll check out what Meta has done with Catron to see some cool things. Cloudflare does a lot of stuff with eBPF and load balancing as well. And so they have a great eBPF team.
Hey, hi Brendan, Shiv again. So I have been seeing that a lot of restrictions have been reduced when it comes to introducing loops, starting from the support for no loops to introducing unbounded loops, and increasing the number of instructions to be analyzed by the verifier. And all. So are there any plan to increase, like to introduce more flexibility or reducing the restrictions even more further, at least from the PL side? Like currently the eBPF programs are like can be developed using restrictive C syntaxes, right? So are there any plans to like to improve even further and allow all the syntaxes of the C for developing the eBPF programs?
Right. So if you've looked at it, it's a good point. If you look at eBPF over the past 10 years, it used to be very limited. We only had like 1,000 instructions or so, a very limited stack. But the maintainers, Alexei Startoyev and Daniel Bachman, kept increasing the limits so that you could do more and more things. And I remember I was at a NetDev conference in Boston where Alexei said, eBPF should be able to run a Rubik's Cube solving application. And he proposed making the instruction count 1 million. And those of us that were there, this is a small private summit, we're like, 1 million, but what do we do? Where are we going with this? Like, we can start porting whole applications to eBPF. That kind of was the turning point when Alexei's like, let's just increase the limits and allow people to do this. Now, if you follow the latest Linux conferences, there's talk about eBPF being the preferred kernel environment for new development. And like, this is really futuristic stuff. What they're talking about is you want to do a new kernel subsystem, you write it in eBPF to start with. I mean, for that to be fully possible, yeah, we're going to need more C things, right? And ultimately, one could imagine the LLVM eBPF backend has enough C support that you can point it to an existing bit of kernel code, like a kernel subsystem, and say, just compile that whole thing to eBPF bytecode. And then it'll hit something that's not supported, and then we'll add it. So we may get to the point where you can point entire subsystems of Linux and use the LLVM backend to emit it as BPF bytecode. And we will have a hybrid kernel. This is like the Plan 9 kernel, where you have user space kernel components that can be easily changed, and it's much more flexible. But Plan 9 didn't really take off. If you remember Plan 9 and Inferno, it was a really futuristic idea. eBPF is allowing us to go in that direction. So yes, we keep adding things. I mean, it was super lightweight to start with, but they have added the bounded loops, a capability to sleep on programs, which is really hard because for a program to sleep, it has to be a schedulable entity. So you need sched structs and whatnot. That's necessary, however, if your program encounters a page fault and you have to sleep until the disk IO has completed or memory's completed. And other capabilities have been added as well. So I think we are heading in that direction. But like I said, at conferences, there's talk about eBPF being the preferred development environment for the Linux kernel, which means we will continue to be giving it these capabilities so it can be general purpose. Pretty interesting.
Thank you. Oh, one last question. Okay.
Brendan, nice to see you again. The question is in the context of BPF time, a very interesting area. And basically what it would allow us to use BPF bytecode in the context of user space applications and do same sort of performance monitoring, observability, and even maybe security eventually. But it is competing with a similar idea, right? Like WASM tries to solve the same problem in a different way. And what I'm trying to understand is, how does BPF time, how would we differentiate BPF time? Because both of them would require some changes to the application itself. So having WASM and BPF time at the same time competing for the same kind of use cases, what do you think, what could be the differentiator for BPF time in the first place?
Yes, sometimes, there's this problem in Linux where Linux is not a company and people are free to do their own thing. And you can have these projects that are similar, and like WASM has a lot of similarities to BPF, the way where it can run things in a sandbox in a virtual machine. And some trap we fall into is when you see these similar projects and you say, oh, there must be a reason. There must be a reason for two projects. And there's no reason. They just overlap. There's like two different companies came up with something similar and off they went. So WASM's pretty interesting. How would I fit that into eBPF and BPF time? That is a hard question, because like I said, it's not like this was planned. If Linux was a company, and it's not, at least there's only WASM and BPF. There are other areas where there's like 17 different similar things. There were 14 different traces when I got involved with Linux. And it's like, why are there so many traces? Why can't we just pick one and then like do it? And that's because there's no way to stop people from creating new ones. So we have at times thought about, should we do a eBPF versus WASM document and talk about the pros and cons of each? But again, it starts from this premise that there must be pros and cons when that's not the case. It's like these 14 Linux traces that I did a blog post where I listed them all that existed. Why are there 14? There's no good reason for it. It's just like people just came up with their own projects. And so it would be at times it would be a sad document where it's like, I don't know why. I don't know why there's like 5 different traces that do the same thing. There's absolutely no reason for it. There's just none. So we can try to write this document of eBPF versus WASM, but I think it's probably not going to be very satisfying because there'll be areas where it's similar. It's like, it's just similar. It is. It's similar. eBPF, I should say, however, WASM has a lot of use on the front end. And so for websites and web development, eBPF has a lot of use on the back end. So at the moment, the biggest difference between them would be their communities. So eBPF is all the kernel engineers, and the back end networking engineers and security engineers, and WASM is the browser engineers and doing gaming and things like that. But apart from that, they're pretty similar, pretty interesting technologies.
Excellent.